Let's talk about CPUs, the Central Processing Unit. You hear about them everywhere: computers, phones, gaming consoles. But what is a CPU, really? It's the tiny, super smart chip at the heart of your device. Sitting on the motherboard, it's the powerhouse that makes everything work. Without it, your gadgets are just expensive paperweights. The CPU is the boss, telling every part what to do and when. Knowing how it works helps you pick better tech and solve problems. In this video, we'll break down what a CPU does, how it works, and why it matters. No jargon, just the essentials. We'll explore its magic, where you find them, and why they're so important. So get comfy. Let's dive in and make you a CPU expert. Ready? Let's go. Think of the CPU as the brain of your device. Just like your brain processes information and makes decisions, the CPU does the same for your electronics. It takes in data from your keyboard, mouse, or apps, processes it, and sends out instructions. For example, when you click an icon, the CPU receives that input and tells the system what to do next. All of this happens in a split second. Without a CPU, your computer is just a collection of silent parts. The CPU brings everything to life, making your device smart and responsive. It's the essential spark that makes technology work. No CPU, no computer. Simple as that. It's the core intelligence running the show behind the scenes. That's why it's called the Central Processing Unit. Let's see what's inside this digital brain. Onward. Deep inside the intricate world of the CPU, one key player stands out: the control unit, often abbreviated as CU. It's a fundamental component, orchestrating the operations within the processor. Think of the control unit as the conductor of a complex orchestra. Just as a conductor guides musicians to play in harmony, the CU directs the various components of the CPU to work together seamlessly. It's responsible for directing the flow of data and instructions throughout the processor, ensuring that everything happens in the correct sequence and at the right time. The CU begins by fetching instructions from memory, retrieving the necessary commands for the CPU to execute. These instructions are the building blocks of every program and operation. Once an instruction is fetched, the CU decodes it, breaking it down into smaller, understandable signals that the CPU can process. This decoding process is crucial for translating human-readable code into machine-executable actions. After decoding, the CU sends precise signals to other parts of the CPU, instructing them on what actions to perform. These signals act as triggers, initiating the necessary operations within the processor's various units. It's important to note that the control unit doesn't actually perform the mathematical calculations itself. Instead, it manages the entire process, delegating tasks to the appropriate units within the CPU and ensuring that everything runs smoothly and efficiently. The CU is the master scheduler, making sure everything happens in the right order, preventing conflicts and optimizing performance. The CU keeps the entire system synchronized, acting as a central clock that coordinates the timing of all operations. Think of it like a director guiding actors on a stage, ensuring that each performer knows their cues and executes their actions at the precise moment. Without the control unit, data processing would descend into chaos. Instructions would be executed haphazardly, and nothing would work together in a coherent manner. The CU plays a vital role in instructing the Arithmetic Logic Unit, or ALU, on what operations to perform. It also manages the flow of data moving to and from memory, ensuring that the CPU has access to the information it needs when it needs it. In essence, the control unit is the ultimate multitasker, juggling numerous tasks simultaneously and keeping all the digital plates spinning without dropping a single one. The CU is often the unsung hero of the CPU, working tirelessly behind the scenes to ensure that your device runs smoothly and efficiently. Ultimately, it's all about precise coordination and impeccable timing, ensuring that every operation is executed flawlessly. Next up, let's dive deeper and meet the CPU's dedicated number cruncher, the Arithmetic Logic Unit. Are you ready to witness some incredible math magic in action? Let's go explore the ALU. Meet the Arithmetic Logic Unit, or ALU, the CPU's math whiz. The ALU handles all the calculations: addition, subtraction, multiplication, and division. It also performs logical operations like comparing numbers or making decisions and or not. Every spreadsheet, total game physics calculation, or simple task involves the ALU. The control unit sends instructions to the ALU, which then crunches the numbers or makes comparisons. The ALU grabs data from special storage spots, does its job, and hands off the result. It's constantly busy powering everything from apps to games. The ALU is the problem solver, making your device smart and fast. Without it, your computer couldn't do even basic math. It's the engine behind every digital decision. Now, where does the ALU get its data so quickly? Let's find out. On to the next part. The CPU needs data fast, faster than RAM can deliver. That's where registers and cache come in. Registers are tiny, ultra-fast storage spots inside the CPU, holding data the ALU is working on right now. Think of them as the CPU's personal notepad. Cache is a bit larger and stores frequently used data and instructions, so the CPU doesn't have to wait. There are usually several levels: L1, smallest, fastest, L2, and sometimes L3, bigger, a bit slower. The CPU checks these caches before reaching out to slower RAM. This system keeps everything running smoothly and efficiently. Registers and cache are the secret to the CPU's speed. They minimize waiting and keep the data flowing. Without them, your device would crawl. Now let's talk about how the CPU actually follows instructions. Stay tuned. CPUs, the brains of our computers, operate by following simple instructions. These instructions are the fundamental building blocks of everything your computer does. At their core, these instructions are basic operations like add, performing arithmetic calculations, move, which involves transferring data from one location to another within the system's memory, compare, assessing the relationship between two pieces of data to make decisions. But what's truly remarkable is that CPUs can execute these simple instructions millions of times per second, giving the illusion of complex and seamless operation. Each program, no matter how sophisticated, is ultimately made up of these basic commands, meticulously arranged to achieve a specific outcome. The CPU reads and executes them at lightning speed, fetching instructions from memory and performing the corresponding actions with incredible efficiency. Clock speed, measured in gigahertz or gigahertz, is like the CPU's heartbeat, the rhythm at which it operates, indicating how many cycles or operations it runs per second. A higher clock speed generally means a faster CPU. Higher clock speed means more instructions processed in less time, leading to quicker response times and improved overall performance. But speed isn't everything. There's more to CPU performance than just clock speed. Modern CPUs have multiple cores, essentially independent processing units, each acting like its own mini CPU, capable of executing instructions independently. More cores mean more tasks handled at once, allowing your computer to juggle multiple applications seamlessly. Or big jobs split up for faster results, a technique known as parallel processing, where tasks are divided and conquered simultaneously. That's why a lower-clocked CPU with more cores, offering greater parallel processing capabilities, can outperform a faster one with fewer cores, especially in tasks that can be effectively parallelized. It's all about efficiency and multitasking, optimizing how your computer handles various workloads. The right balance of speed and cores, tailored to your specific needs and usage patterns, makes your device powerful and responsive, providing a smooth and enjoyable computing experience. Next, let's see where else CPUs are hiding in your life, beyond your computer or smartphone. You'll be surprised to discover how pervasive these tiny powerhouses have become. Let's explore the hidden world of CPUs. CPUs aren't just in computers, they're everywhere. Your smartphone has a powerful CPU, often called a system on a chip, running apps, calls, and videos. Smart TVs use CPUs to stream movies and run apps. Even your smartwatch has a tiny CPU. Gaming consoles like PlayStation and Xbox have custom CPUs for graphics and game logic. Modern cars are packed with CPUs controlling everything from the engine to safety features. Household appliances, fridges, thermostats, cameras, even toys have CPUs inside. They make devices smart, connected, and efficient. CPUs are the invisible brains of our modern world. They power convenience and innovation everywhere. Next, let's talk about why the right CPU matters for you. Performance isn't just for gamers. Here's why. The CPU you choose affects everything's speed, multitasking, and battery life. A faster CPU means quicker programs, smoother games, and effortless multitasking. For gamers, video editors, or programmers, a powerful CPU is essential. It can save hours on demanding tasks and make your experience frustration-free. But it's not just about speed, power efficiency matters too. Efficient CPUs give you longer battery life and cooler devices. Manufacturers balance performance and power to suit different needs. When buying a device, check the CPU's model, clock speed, core count, and generation. Newer CPUs often mean better performance and efficiency. The right CPU is an investment in your digital life. Choose wisely for the best experience. Now, what's next for CPU technology? Let's peek into the future. CPUs have undergone a monumental transformation. They've evolved from colossal, room-sized machines that filled entire spaces, consuming vast amounts of power, to the incredibly compact and efficient tiny chips we see today. These chips now fit into the palm of your hand, yet possess computational power that dwarfs their predecessors. But the innovation never stops. The relentless pursuit of faster, smaller, and more powerful processors continues to drive advancements in the field. More cores are coming, and they're not just incremental additions. Some CPUs now have dozens or even hundreds, pushing the boundaries of what's possible in parallel processing. This allows them to handle more tasks at once, significantly improving performance in demanding applications and complex workloads. Imagine the possibilities for scientific simulations, data analysis, and content creation. New materials like graphene and carbon nanotubes are being explored. These cutting-edge substances could revolutionize chip manufacturing, potentially making chips even faster, more energy efficient, and more durable. They promise to overcome the limitations of traditional silicon-based technology. Chip designs are changing, evolving beyond the conventional architectures we've become accustomed to. We're seeing a rise in specialized processors for AI and graphics, designed to accelerate specific types of computations. These specialized units are working alongside the main CPU, offloading tasks and freeing up resources. Neural processing units, NPUs, are now common, integrated into many modern devices. They're optimized for tasks like voice recognition and image processing, enabling faster and more accurate performance. This team approach boosts efficiency and performance, allowing devices to handle complex AI tasks with ease. And then there's quantum computing, a paradigm shift in how we process information. It uses qubits that can be 0, 1, or both at once, leveraging the principles of quantum mechanics. Quantum CPUs could revolutionize certain types of computing, tackling problems that are currently intractable for classical computers. We're just at the beginning of this journey, exploring the vast potential of quantum computation. But the future is exciting, filled with possibilities we can only begin to imagine. The CPU will keep evolving, adapting to the ever-changing demands of the digital world. It will continue powering the next generation of technology, driving innovation across all sectors. Stay curious, tech is always moving forward. The world of CPUs is a dynamic and fascinating one, constantly pushing the boundaries of what's possible. Thanks for watching, and keep exploring the world of CPUs. There's always something new to discover in this ever-evolving field. See you next time.